Good morning. We're going to look at section 6.4, rational exponents. Rational exponents. And rational means a fraction. So what I'm talking about here are fraction exponents. And what we need to do for our fraction exponent sections is combine our ideas about fractions with our ideas about exponents. This is combining ideas that we already have into just putting them together. I say just, right? Like it's going to be just that easy. So let's look at a couple of examples here. First, let's say we have this. I have 5, or let's just do x. X to the 1/2 power times x to the 1/3 power. And when we're multiplying our terms here, we're going to add the exponents together. So if this is x to the 2nd plus x to the 3rd, that would be x to the 5th. You just add those together. Well, what's 1/2 plus 1/3? Well, common denominator of 6. Hang on, let me do this in a couple steps here. Common denominator of 6. So this will be x to the 3/6 times x to the 2/6. And now I can add these together because I have a common denominator. So this will be x to the 5/6 power. Now what does that even mean, to have x to the 5/6 power? Don't worry about that for the moment. Just go along. All the rules work. I will just promise you for now that they'll work. We'll worry about graphing and looking at what they actually look like at a later time. Okay, so we have another rule concerning exponents. Right? We have 5. Okay, let me draw a squiggly line here to separate these. Squiggly line. We have 5 x squared y to the 3rd. All right, and we're going to have a fractional exponent here to the 1/5 power. Well, when we have this, you multiply the exponent on the outside by all the exponents on the inside. So this is going to equal 5 to the 1/5. Remember, if there's no exponent, it counts as 1. 1 times 1/5 is 1/5. 1/5 of 2 is 2/5. X to the 2/5. And then y to the 3/5. So I multiply 1/5 by each of the exponents times 1, 2, and 3. None of those reduce, so just leave them as they are. But always reduce a fraction if you can. Okay, let's look at, I want to combine this with our ideas about radicals here, and just what that means as far as our exponent is concerned. So the 3rd root of y to the 5th power, well, this root here, and I think we've talked about this briefly before, but let's get more into it now. This is the denominator of your exponent. So this is going to be y to the 5/3 power. Okay, and that's all I'm trying to say, though, is that the index is the same as the denominator of the exponent. These two just mean exactly the same thing. So one thing we can take away from this is that if you have an exponent and an index that can reduce, you can do that. So it's kind of cool. Let me see here. I think that's it for the rules, except for one more thing. If you have a negative exponent, it starts with a negative fractional exponent. So if I have something like, let's say, 4 to the negative 1/2 power, and I'm going to work this out. This is going to give me a number here. So 4 to the negative 1/2 power. The first thing I need to note is that it's negative, and a negative exponent puts your value in the denominator. And when it goes into the denominator, that exponent becomes positive. Okay, so negative exponent puts your expression in the denominator. Okay, well, 4 to the 1/2 power, this is 4. This is your index, so 1 over the square root of 4. Okay, so 4 to the 1/2 power, that denominator becomes the index. And then it was just 4 to the 1st power, but I'm not going to write that 1, so the 1 goes away. And actually, this 2 could go away as well, right? If I don't see any number there for the index is just 2. And then, well, what is that? Well, that's just 1 over 2, right? The square root of 4 is 2. So those are your notes for rational exponents. Again, it's just combining ideas we had before. Maybe we need a little bit more refreshing on those, but we'll do that as we work through some examples. And that's it. Can I squeeze them all into one screen? Yes! Those are all your notes for rational exponents, just combining the ideas that we had before.